Hi guys, today we are off for math. We are looking at area and perimeter, and we've got lots to do, lots to practice. This is something we haven't talked about in a while since we've been out of school, but it's a very important skill, so we're going to go ahead and get right into it. And so today we are going to be calculating the area and perimeter of different rectangles. This is part of our lesson of 9.1. So lucky you, we would normally take it in a math test by now over chapter 8, but we're going to jump right on into unit 9. This is something that's real life, so we really had to figure this out when we wanted to put in a fence around our yard for our puppies. And this might be something that you would want to do if you got a new puppy. You might want to build a pen or a fence. And so the outside would be the perimeter. How much fence would you actually need to go around? And then the area would be how much grass and area on the inside would you want them to be able to play around in. So this is a real life skill that we use all the time. Remember, perimeter, we think of when we put our fingers together. When we do this in class, we think perimeter at, and we even put our fingers together and show the plus sign. We think perimeter at, perimeter at. And when we think of area, we think of how the A comes together, and if you kept going, it would make like an X, because area multiply, area multiply. We normally put our hands together and make an X to help us remember area, the inside of the shape. Sometimes they give us these little square units here in the middle that some of you like to hip hop around to count the perimeter. Today, and then count the little boxes for the area. Today, though, they're not going to give us the boxes to help us. Today, it's going to just tell us this is 7, and they're going to tell us this is 3. And we're going to have to know to multiply the length times the width, just like it says. And for a perimeter, we're going to need to be able to say, okay, this length is the same as this length. This length is the same as this length, because in rectangles, it's the opposite. It will be the same since they're parallel. So 7 and 7, 3 and 3, and you would need to add that up together to find the perimeter. There's going to be one problem on here that for your work today, that you're going to be seeing a rectilinear figure. And that means it kind of looks like this, where it's two rectangles, they've kind of smushed together, and you're going to need to be able, for the first step to success, to be able to divide that into two smaller rectangles. And you can see that I did that here. That seemed like the logical place to divide them. You're going to calculate the area of each one of these smaller rectangles. So it told me the length and the width for 9 and 7. So I multiplied those together to equal 63. Here the length and width were 10 and 8. Multiplied those and found 80. So now I need to be able to add both of these smaller areas together to find the area of this whole large rectilinear figure. So I added 63 plus 80, which gave me 143. So the area of the whole figure is 143 meters. Now to find the perimeter, it's a little bit different. You don't need to divide it up because, again, we're looking at the outside. And today they're going to have given you all of the measurements for the outside. And so our step to success is to add some of the sides together, small pieces at a time, to help us. We don't want to try to add all of it up together all at the same time, because that's when we make mistakes. So just divide up into smaller pieces and cross them out as you do. So for here, I know that I did 4 plus 14. 4 plus 14 was 18. Then I did 8 and 4 here, so 8 plus 4 is 12. Then I did 6 and 8. 6 plus 8 was 14. So now I'm going to add up all of the measurements that I had that were smaller, and I'm going to add them up down here. 18, 12, 14. I always make sure I write it up and down, up and down. And when I added those up together, I found out I had to carry over the 1, and I found the answer was 44. So the perimeter here is 44 centimeters. So I'm going to be given two rectangles here. Just like I said, they gave me the length and width. I need to figure out what's the perimeter and what's the area. And so I'm going to go ahead and think for the area, I'm going to multiply 6 times 3. 6 times 3 is 18. I can make an array if I would like. If you want to check your work, that's always okay to do. For perimeter, you're going to think, okay, if this side's 6, I know the opposite is 6. If this side's 3, this side's 3. I'm going to add them up. 6 plus 6 is 12. 3 plus 3 is 6. 12 plus 6. 2 plus 6 is 8. And bring down the 1. Oh, well, look at this. The perimeter and the area are the same. That does not always happen. That is unusual. All right, let me look at the next one. I like to do the area first because it already gives me the length and width. So you can start with the perimeter if you want. I just prefer to do the area. 9 times 2, well, I know that's 18. Again, if you would like to make an array and check your work, that would be a great thing to do. And it tells me I need to write the unit, and I know that that would be square feet. It tells me right here that the unit is in feet. And since it's area, I know I'm thinking about counting those squares on the inside, so square feet. And the perimeter, if this side's 9, I know this side's 9. If this side's 2, I know this side's 2. I'm going to add up 9 plus 2, 9, 10, 11. So I'm going to add 11. Well, this is 9 and 2. That's the same thing. So it's going to be 11 and 11. Add that up. It's going to be 22. So this perimeter and area are different. And this would not count the squares on the inside. So this one's just going to be feet for the unit. And what I noticed here is that the areas for both of these shapes, pin A and pin B, are both 18. Now the perimeters end up being different. And that's something I want you to notice today, that rectangles and different shapes can have completely different looks to them. This is long and skinny. This is more of a box shape. They look completely different, but they have the same area. And that happens sometimes when we think about those factors. Remember that sometimes the products would have different factors, but then have the same product. And that happens. But just like when we add things up, they don't always end up being the same. So when you go to work today, I want you to be practicing the different types of perimeter, practice different types of area. Here's even where you try to do the rectilinear shapes perimeter, and the rectilinear is the complex figures is what they say for area. There's relationship, there's all these different things. Now, I didn't put all these for you to do. These are all options. You don't have to do all of them, but they are a great review. And when you go to do the you do, it says find the area of each one of these shapes, just like what I did in my model. And then it says circle the shapes that have the same area, just like when I noticed in my model, these both had the same area. So I would have circled both of these together because they both have the same area. And then it says cross out the shapes that do not have the area of 16. So that means that you'll cross out the ones that are not the same. Then it asks you to go through and figure out the perimeter, and it asks you to figure out which one would have the shortest perimeter for you. Okay, so that's going to be something that you're going to need to look here and add up all the sides, figure out which one is the shortest perimeter. All right, so when you're done with that, you're going to get on Flipgrid, and you are going to reflect on how you were able to figure out the areas and the perimeters here when you were solving this page. All right, let me know if you have any questions today on Google Meet, or you can email me. Have a great day.